In this video, we're going to talk about hyperbolas, and we're going to specifically talk about hyperbolas that are centered at the origin. So I've written the two forms of a hyperbola up here as number one and number two. Number one is going to have it's gonna open to the left and to the right, and number two is gonna open up and down. So um, I'll go ahead and show that to you, that this first one here, just sketch a graph of it, even though we weren't told to graph it, is going to have vertices at 0, +10, and 0, -10. Those are going to be points that are on the hyperbolas, and we're going to have asymptotes that go through the origin there because they have a y-intercept of 0 and they rise 5 and run 2. So to get up here, we're going to have to go 1, 2, 3, 4 to be part of this box. 1, 2, 3, 4, and here and there. Those are the corners of the box that is made by the asymptotes. You can just imagine this box right here that goes through the vertices, and this distance here to the vertex is A, and that's up and down. And then this side, so this distance here is A, and this distance here is going to be B. So B, A is 10, B is going to be 4. We can also get 4 by looking at the asymptote, which is in the form of A over B. 10 over something had to be equal to 5 over 2. And we can solve that and say 20 is equal to 5b and divide by 5, and b is equal to 4. So to write this equation here is going to be y squared over 10 squared is 100 minus x squared over 4 squared is 16 is equal to 1. And our, keep going here, here, and here, and here, and these pieces of the hyperbola approach these asymptotes. Like so. All right, let's look at the second one that has vertices at x equals plus or minus 3. And so they're going to define the side of my box here. And then I have foci at plus or minus 11. We haven't talked about foci yet. 4, 5, 6, 7, 8, 9, 10, 11. 4, 5, 6, then 8, 9, 10, 11. This is F1 and F2. And what you need to know about foci is that in a hyperbola, it follows the Pythagorean theorem that a squared plus b squared equals c squared. So I have my a is 3. So 3 squared plus b squared is equal to 11 squared. So b squared is equal to 121 minus 9. B squared is equal to 112. And so my equation here is going to be x squared over 9 minus y squared over 112 is equal to 1. And the square root of 112 is a little bit bigger than 10, but not quite 11. So 1, 2, 3, 4, 6, 7, 8, 9, 10. So we've got a box that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that corner to corner through the center are asymptotes. And so going to approach like that and like that. All right, this it's like so. Okay. And kind of get the idea that if I turn these pieces towards each other, that they would kind of make an ellipse in here. And those ideas are related. The A and the B are related there. If this had been a plus sign instead of a minus sign in the formula, I would have gotten an ellipse. So let's go ahead and let's find the equation and sketch the graph now for these next few. These are, let me go ahead and write this equation for you. There we go. No, this was 112. There we go. So the center's at 0, 0 again. The focus is at 65, 0, which tells me that it opens to the left and to the right. So that's going to be the first one here. So this opens left, right, and this opens up, down. I have that backwards. Sorry. This opens left, right, and this opens up, down. And so we're going to have this first kind here, x squared over a squared and minus y squared over b squared is equal to 1. And they tell us that c is going to be the square root of 65. So c squared equals 65. We have a vertex a equals 7. So a squared is going to be 49. And that goes here. And then 65 minus 49 gives me 16. And there's our equation. And we're going to graph this, that we're at -7. Zoom in a little bit here. -7 and 7. And we go up to 4 here to get to this corner of our box, and down 4 there to get to the corner of the box, 4 and 4. And we make our asymptotes. Like so. And we're going to make a graph like that. Now our vertex is at 0, 7. and 0, -7. Our focus is at 0, square root of 58. So these are going to open up and down. So we need a 9 there to add to be 58. So we need to go 3 and 3 and there and there. There's that asymptote. And there's that asymptote. We need to stay between them. Like that. All right, that's going to be it for this video. Come back next time and we'll take an equation. We'll find its center, transverse axis, vertices, foci, and asymptotes.